right. All right. So good evening and welcome everyone. My name is Siddhi Redis. I lead marketing operations at Onnivation. Firstly, would like to thank everyone for dedicating your time to be with us today as we're gonna talk about transforming cloud data security for modern organizations. With that, I would like to introduce our speaker for this webinar, Dan Benjamin, CEO and co-founder of Dig Security, one of our best cybersecurity partners from Israel. Dan is an entrepreneur with strong skills in both technology and business. He has worked in the industry for over a decade now, gaining experience in both startups and large companies. He has led teams of technical experts, developed and maintained solutions for large-scale operations, and designed products for various industries as well. Being a co-founder of Dig Security, he's now reinventing the world of multi-cloud data security. Very, very excited to have you with us, Dan. Over to you. The stage is all yours. Thank you.
Fantastic. Thanks for the introduction. I'm very happy to be here. I'm going to share my screen. Just give me a heads up once you're able to see it. Sound good?
Yeah.
Perfect. So I'm guessing you should be able to see my screen right now.
Yes, we can see your screen.
Perfect. So hi, everyone. Thanks so much for dedicating your time today. I'm Dan. I'm the co-founder and CEO of Dig Security. Dig Security is a cloud data security company. So we help organizations protect their data on AWS, Azure, GCP, Snowflake. We're pioneers of a new category called DSPM, Data Security Posture Management, which essentially talks about how do we visualize and prioritize risk from the data itself? How do we build data-centric security? And also pioneers of a category called DDR, Data Detection and Response, which is kind of the evolution of DLP for public cloud. How do we detect and respond when something bad happens with our data? We're a team of 60 around the globe, raised almost $50 million. All of us are second-time founders. And my co-founder, God, sold this company to Mimecast. He built a French company called Tuluna. And quickly about myself, 20 years in cybersecurity, starting in the Israeli army in the 8200 units. After that, sold my first cybersecurity company to a company called CA back in 2014. Spent many years at Google Cloud, many years at Microsoft. At Microsoft, I led SaaS security. And my last position at Microsoft was leading the multi-cloud security strategy for Microsoft. So very relevant in dry space. And the reason that I left Microsoft to co-found Dig was because all my customers kept asking me the same exact questions around data, and I didn't have good answers. And if I kind of boil these questions down into the three main questions that all my large customers essentially started asking me was, first off, what data do we even have across our clouds, across AWS, across Azure, across GCP, across Snowflake? This sounds like a very simple question to answer. I would say that the vast majority of enterprises today cannot answer this question today. Second, of course, is how is that data being used? Which applications, users, vendors, contractors are touching which pieces of information? And lastly, how do I protect that data? Either at rest, in motion, or in use, or how do I protect that data from specific scenarios, whether it is data exfiltration or ransomware or compliance breaches or data misuse? I would say that today, 90% of the organizations can't answer the first question, and approximately 99.9% of the organizations cannot answer the three combined. We just don't have the right tools in the world of cloud. And if we kind of think about this from a mindset of an attacker, which is how I started my actual career, data stores in the cloud are always the target for an attack. That's where you can actually make monetary value from attacking an enterprise. But it's also the only place today in the public cloud that lacks a dedicated security solution to protect it. We have EDRs to protect our VMs. We have NDRs to protect our networks. But we don't really have a DDR solution to protect our data. Now, the reason that it's becoming so hard, it's because we have this explosion of information. We as an organization started running across multiple clouds. So now we've doubled or tripled or quadrupled the variety of data assets that we now need to protect. We have microservices. So each organization now has smaller services and each one of them is tied to their own data asset. And we also have multiple deployment modes, which we used to not have this on-prem, right? So we have PaaS services, anything that we can consume from the cloud, like AWS RDS or Azure SQL or Google BigQuery. We can have anything IaaS based, right? So anyone can boot up a VM, install MongoDB on it, and start saving sensitive information on it. And then, of course, we have the new data clouds, Snowflake, Atlas, Databricks. And that kind of led to a typical enterprise today having at least 20 different types of data assets that they own, and thousands, if not tens of thousands, if not hundreds of thousands of data store instances. And that's kind of where we started Dig from. Dig is a data security platform, and our goal is to protect data in the multi-cloud era. Everything starts with discovery. We're able to find any type of data store that lives in a customer cloud automatically. PaaS services, IaaS services. If you ever use kind of a Gen 1 product of data security, whether it's Varonis or a Big AD or any kind of the older products in the past, they used to say discovery, but they never actually discovered anything. The first thing that you essentially had to do once you install them is now manually connect them to hundreds, if not thousands of data stores. Now, most organizations don't even know which data stores they own. And second, connecting a single system to thousands of data stores, not only it's a massive security risk, but it's also time consuming. That's what kind of led to typical enterprises today taking years building a data security program. At Dig, not only we discover the data stores automatically, we're able to find VMs running a database or managed services running a data store. We also auto-classify the information. So Dig supports both unstructured data like files, but also structured data like RDS and DynamoDB. And we auto-classify the information. So once we're connected to the customer's cloud, we have a component that essentially for each type of data store that we find will always kind of generate the same technique. So it will either take a backup, an export, or a snapshot of a running data store, mount it on the side inside the customer's cloud, and do the data analysis. So in less than 24 hours, in a typical environment, Dig will have a full map of your data. Now, once we discover the data, classify the information, we bring context to the data itself. Context is a very big word. But first off, what kind of data do we have? Where do we have PAI or PHI or PCI or any type of regulated data? Now we have kind of the new data privacy law coming in India, which is kind of a big topic that a lot of our customers are talking about. Where do we have sensitive data just as an organization, sensitive data to us? Where do we have data misconfigurations, like data that is not encrypted or data that is being replicated in a bad fashion? Where do we have data access permission issues, whether it is by applications or user? Where do we have data sovereignty issues? Sovereignty is becoming, again, a very big topic. Each country has their own kind of GDPR topic, right? India has the same. And of course, where do we have data exposure? And the combination of the first two columns of what we kind of just talked about now is essentially what Gartner now calls DSPM. And then Dig is one of the leading vendors in the category. Now, on the other side of it, we still understand that we're going to have hundreds, if not thousands of people, machines, vendors, contractors, and all of them are going to have access to this data. But that access goes completely unmonitored. So let me tell you a story. Dig onboarded one of the largest banks in the US. And when we onboarded this large bank, what did we discover? We discovered that for the past 3 years, they had a cron job running, an automated procedure that was running every single day at 3 p.m. What did that cron job do? Every single day, it copied all their financial reports from a single bucket to an external AWS account that doesn't belong to them. 3 years, for a public American company, all their financial reports were being copied outside. This is nuts. Now, how did they not discover this? Because no one today really monitors how data is being used after we give permissions. We don't have the tools. So at Dig, what we did is we modeled scenarios. We studied hundreds of different types of data breaches, and we built what should never happen with data. And today we can discover anything that used to lead to a data breach. Data being copied outside of your clouds, mass downloads, mass uploads, some of the disabling backups or making an asset public, someone copying data from a PCI environment to non-PCI environment, someone copying data from a residency area to non-residency area. And we combine that into a single platform. We combine both data security posture, but also data detection response. And we do this without deploying any type of agents or proxies. We integrate into a customer environment in a couple of minutes. And we have zero interference with the customer's cloud because we're completely out of that. So how does this whole thing work? We typically use 3 main types of technologies. The first one, of course, is cloud-native APIs, where we do our discovery, our metadata, and posture. The second, of course, is cloud-native logging for our detection and response. So we look at admin events and data events and connections. And lastly, we have an outpost, and that outpost sits in the customer's environment. And that is the actual component that does the data analysis without copying any information out. Dig will never see your data. We don't copy any information out. Everything is being processed in your residency area. So wherever the data sits, the outpost will essentially run in that specific region to do the data analysis. And that's how we work with banks and insurance companies and retailers and healthcare and tech companies, anyone that has sensitive data to essentially protect in the cloud. So before I kind of switch over to a demo, which I think is always fun, anyone in the crowd has any questions so far? You can feel free to write it in the chat or the Q&A. Happy to answer any questions. And if not, I'll switch over to a demo itself. Don't be shy. I'll give it another 10 seconds, and if not, we'll switch over to a demo. Okay, so, oh, there we go. How do you handle, so the question was, how do we handle data collection, storage, and management? So Dig does the data analysis in the customer's cloud. So we don't actually copy the information out. Typically, we have a component that we call the outpost that essentially every type of data store that it finds, let's say it's an RDS, for example, it takes a database export or a snapshot or a backup. It does the data analysis in the customer's cloud on a separate machine, does the data analysis. Once we finish the actual data classification, we essentially remove that backup, the export, or the snapshot. And that's kind of how we do for every type of data store out there in the market. If it's a DynamoDB, we do the same thing. If it's a Redshift, we do the same thing. Or an Azure SQL, it's the same kind of process. So everything, the actual data stays in the customer's cloud. We will never see it. The outpost, what essentially is the actual component that does the data analysis itself. So that's on that aspect of it. Hopefully that answered the question. Second, of course, and I'll maybe kind of show this small little architecture here that is high level, of course, but as you can see, we have this outpost that sits in the customer's cloud, one per cloud typically. And the only thing that essentially is being collected or visualized outside is, of course, the metadata and the insights. So we found credit cards in file X and bucket Y and account Z. And that is what we present in the dashboard that in a second you're going to see. But we never send out any sensitive data outside of the customer's environment. The second question is, how is the cost model? So the cost model is per data asset. Dig prices per data asset in the customer's cloud. In a second, I'll highlight kind of how I'll switch to the product demo itself. And the third question was, can I use Dig outputs for data classification requirements for ISO 27001 and GDPR? Yes, definitely. We have a lot of customers that are essentially looking at Dig to essentially help them comply with data regulations, whether it is PCI or HIPAA or GDPR or ISO 27701. We help you identify sensitive information that is regulated. We have a lot of compliance regulations that are mandatory for specific countries, like LGPD in Brazil. And we help you kind of cope with those and highlight where do you have data that is outside of a residency area or data that is violating PCI, for example. Any additional questions before I switch over to the actual product demo? Yes, another one. What kind of sensitive authentication data is identified in PCI? I'll show that in the product in a second, but we can identify credit cards and IBANs and SWIFT codes, routing numbers, anything like that, but I'll show that in the product in a second. Dig supports around 130 different types of classifiers today, and we constantly add additional ones. And of course, customers can build their own types of classifiers, but I'll show that in the product. Cool. So let's switch over to the product. I'm sure that this will bring in a lot of great questions as well. And feel free to kind of push additional questions over. Let's make this as interactive as we can. So I'm going to switch over here. And I'm guessing that you should be able to see the Dig Security platform now. Yes? Okay. So this is the Dig Security dashboard. And the first thing that we'll do when we come into a customer environment is, of course, we'll connect to any type of cloud infrastructure that they have. It can be AWS, it can be Azure, it can be GCP. They will automatically connect to any type of cloud project subscription that you have. We can also connect to the entire organization and tenants. Now, once we find these different data, once we connect to these different types of data stores, we essentially find any type of data store that lives in the customer's environment. It can be managed data stores, like buckets and storage accounts and BigQuery data sets, but it can also be VMs running a database. So if it's a VM running a Postgres on Linux, we'll be able to find it, or if it's a VM running an MS SQL on Windows, we'll be able to find it. Dig supports, I think, almost 60 different types of data stores that customers can run, which is basically the entire market. And we're able to find and visualize that information. Now, in addition, once we find these different data stores, we visualize where do we have these data around the globe. A lot of our customers have data residency issues, specifically in regulated environments, which I think is most of the world today has their own privacy regulations around data. And we're able to visualize where do we have data around the globe. Now, the first thing that we'll do is we'll build a full data asset inventory. So we're able to find and visualize all the information that lives in the customer's environment. First off, of course, for each type of data store, we're able to visualize all the information about it. So what kind of data store is it? Is it encrypted, private, or public? Who created this type of data store and who last modified it? This is, of course, coming from the activity logs, because we look at every type of data interaction and then we're able to identify that. Any tags. Is this asset actually being used? Because sometimes we have a lot of data that we don't actually use anymore. So we're able to identify assets that are being used or not. And of course, all security information about it. Do we have versioning in place? Do we have data retention policies? A lot of our customers have to delete data because of specific compliance regulation after a certain period of time. And of course, do we have the right logging in place so we can detect if something bad happens? Many of our customers, for example, because they have PCI data, they need to log any type of data interaction with that PCI information. But then they don't have any logging enabled, and they can't detect if someone does something bad with that information. So Dig is able to visualize that piece of information. And of course, then we're able to see all the information about the data stores themselves. So first off, of course, what kind of content lives in this type of data store? So total number of files. Do we have any types of database backups or dumps that were just thrown in a specific bucket? We call these shadow backups. The reason that we call them shadow backups is because typically they're not being monitored by anyone. Most organizations don't even know that they exist. And typically the reason they are high likely of getting breached. And why? Because it's a high value asset. Sometimes you'll have in a database dump, you can get 3 million records of PHI or PCI data. So Dig is able to visualize and find that. Of course, do we have any files that are open through ACLs, for example, and we're able to find them as well. And then, of course, any type of sensitive data that we were able to find in the customer's environment, whether it is credit cards, SWIFT codes, IBANs, we're able to see all the information that lives in the customer environment. We'll tell you which file it is in. Dig supports any type of file out there in the market, whether it is PDFs, Excels, CSVs, JSONs, text files, PPTs, anything out there in the market, JSON, zips, Parquet. And every time we find a piece of information, we'll always kind of give you a mass example so you can kind of validate the results themselves. Customers can, of course, build their own types of classifiers. And we have customers that build loyalty numbers, membership cards, routing numbers. We had a customer that built a recipe inside our classifiers as well. So we're able to find those as well. And of course, we do this and we support both structured and unstructured data. So this is in RDS, for example, and we're able to see that we have 21 columns, but only 11 of them are sensitive. We're able to see all the information that we're able to find, what percentages of the rows we were able to find it in, which database it's in, which table it's in, and we're able to highlight that automatically as well. So when Dig is installed in your environment, the only thing that you need to do is connect it to your cloud infrastructure, to your cloud, AWS or Azure or GCP, and Dig will automatically do the data analysis. Now, for each type of data store, we also have open alerts, which we're going to deep dive in a second. Any event that happened on the data store itself. So who did what and when with the data store? Any misconfiguration based on the different compliance frameworks. Active identities, who's touching the data? When did they last touch it and how? And of course, any risk associated with the data itself. And we aggregate all of these risks into a static risk page. So show me all sensitive data today that is not encrypted, or show me all sensitive data that is also exposed to the world. If it's exposed to the world, we even are able to see that we have a public path to the file. We see many of those. Show me all data flowing outside of Europe, violating my GDPR policies. Why is this data being copied to the US? Or show me all data flowing outside of California, violating my CCPA policies. Show me all data flowing outside of production to a dev or staging or test environments. Why do we have that replication that is being copied from production to dev, right? Or show me all data flowing to accounts that don't belong to us. This is not an account that essentially belongs to the organization. Why do we have data being copied there? Show me all shadow backups, for example, in my environments. Shadow backups, as we discussed, high value assets. Access that other accounts or other vendors might have to our environment. Sometimes we will tell you, by the way, we've never seen this account. Okay, so we don't know who this is, but why does he have access to our information? Sometimes we will tell you, by the way, we know this account. We've seen it in the past. This is Cloudinary. But why does Cloudinary have access to our PCI data or PII data? Orphan snapshots. Orphan snapshots is a very big topic that a lot of organizations are talking about. In my opinion, it's one of the largest pandemics in the cloud. What is an orphan snapshot? An orphan snapshot means that someone once took a running database, took a snapshot of it, and once he finished taking the snapshot, he deleted the original database. Now, typically, these orphan snapshots are not encrypted. They're very large in size. They cost a lot of money, and typically they're not being monitored. So this is exactly how Imperva got breached. Imperva got breached because an attacker found these database snapshots, took the information away, and because no one knew that they existed, no one was monitoring them. This is also a big cost factor in a lot of organizations. Just a couple of weeks ago, we helped one of our customers drop $130,000 in cost of their storage every single month, just by deleting orphan snapshots that no one was using. We even offer malware analysis in the cloud. So this is something new that we recently launched. Any customer of ours that also uses CrowdStrike, we use the CrowdStrike malware analysis engine, and we're able to find malware in the customer's environment as well. So lastly, kind of on the discovery and classification piece of it, before we switch over to like detection and response, we build a full map of your data. Where do you have sensitive data around the globe? What kind of sensitive data do you have around the globe? It can be social security numbers, it could be phone numbers, emails, it can be credit cards, ethnicity, date of birth. It can be healthcare information, like PHI data. It can be developer secrets, Azure Storage Account keys, GitHub tokens, certificates. And it can even be, of course, PCI data, Swift codes, IBANs, credit cards. And whenever we're able to detect this, let's say, for example, we as an organization might say, we should never have social security numbers in our environment. Not only we're able to see which clouds it's in and what kind of information, we're able to see where do we have these around the globe, which assets do we have them in, and of course, where do we have concentrations of this data. Here, we're able to see that it's, in a very simple way, we're able to see that this organization, the vast majority of social security numbers is in a single bucket in AWS. And if we kind of deep dive into this one, we're able to see that it's just a simple Excel file that someone once dumped in a bucket and forgot about. And if we basically delete this one, we basically eliminated all social security numbers from the environment today. So this is kind of a very easy example. And up until now, we kind of discussed not only discovery of the data, classification of the data, identifying risk across the data itself. Of course, data classification and data flows. And before I kind of switch over to kind of detection and response, any questions so far? Let's kind of do this exercise again. Feel free to kind of send a couple of questions, and then I'll switch over to detection and response. And then, of course, how do we onboard them in other environments? I'll give you 10 to 15 seconds to write some questions, and if not, I'll continue moving forward. Great questions. So I'll start with kind of a couple. I see a lot of them. So do we integrate with third-party tools and platforms that we currently use? I'm not sure which ones, but of course, Dig connects to SIMs, with SIMs, SOARs, messaging solutions like Slack and email, anything that essentially supports webhooks, we can do. We can, of course, connect to CrowdStrike as we run the malware analysis engine in the customer's cloud. But we're constantly building additional integrations. So Jira, ServiceNow is coming soon. We're building integration with some of the CSPM vendors out there in the market. So a lot of kind of big integrations are coming up or already exist in the product itself. Happy to kind of show that in a second once we kind of go to the integrations tab. Second, hey Dan, I see that Palo Alto and Orca would bundle cloud data security with their products and position themselves as pioneers. How does Dig offering just cloud data security from a POV and cost and SLA? So first off, Prisma today doesn't have any data security offering at all. They are looking at Dig to essentially offer that as a bundle into their product. But Prisma today doesn't have any data security offering at all. Orca started a little bit with bucket classification, but typically when we come into an organization, their data security needs are so vast. They have privacy functions, they have GRC functions, they have compliance functions, they have security functions. You need to dedicate a data security product today. Organizations have data security teams. You have privacy regulations coming up. A small little tab in a specific CSPM product that was never built for data security teams cannot really help you there. All of our customers have a CSPM solution, or the vast majority of them. But that CSPM solution was built for DevOps. It wasn't built to serve data security needs. So most of our customers already have a CSPM, and they get Dig for the data security needs, data security, privacy, and compliance needs. Okay. The second question is there an option to choose only data security from only data discovery from the solution? I'm not sure I understand the question, but Dig kind of does everything. So we do both data discovery, data classification, data posture, data risk, detection response. But happy to kind of talk about that like later on and understand the specific scenario. What kind of machine learning or AI capabilities do you offer for optimization and predictive modeling? That's a great question. So I think the question kind of aligns around how does Dig do data classification? When we kind of talk about data classification, we always say that we use 4 tiers for data classification. And it kind of operates as kind of a little funnel. So when we do data classification, we pass the data through kind of multiple engines. First off, of course, regex, the very obvious thing. We look for patterns in the actual data across, I think, 130 different types of classifiers that we already support. And we start minimizing the sets of results. For each type of data classifier, we also have context words that amplify or de-amplify the word. Now, context, again, is a very big topic because context can be derived from multiple locations. It can be derived from the file name. It can be derived from the column name in the CSV. It can be derived from the key and value pairs in the JSON. It can be derived from the columnar or row-based kind of information and kind of the additional adjacencies that you have in the row in the database. And we kind of push that into the data classification engine and amplify or de-amplify the results. Third, for each type of data classifier, we also use context words. We also use like validation functions. And validation functions essentially validate the results. For example, in credit cards, it can be Lanza algorithm that validates the authenticity of a credit card. We sometimes validate checksums or structures. So for each type of classifier, we also have like validation functions, and that also minimizes the sets of results. And lastly, if needed, we run models on the actual subset of the results to, again, reduce or eliminate any type of false positive that might run in an environment. I would say that Dig analyzes today approximately almost 300 petabytes of data across customer environments. We barely have false positives. Customers are very happy with the results of Dig because we're not a regex engine. We do so much more in data classification. We have a team dedicated to that. I think a team of almost 10 today that only do data analysis, data classification. They build and amplify this engine. And when you kind of think about data classification in general, you always kind of combine that into multi aspects of it. It needs to be efficient because it needs to run across a lot of data. It needs to be accurate. And it needs to run across vast amounts of data. Even in a small environment, you might think that that you don't have a lot of data. You might have a petabyte of data. That's a lot of information. And if you don't scan efficiently, it's going to be very, very, very costly. So Dig is kind of specialized in that. I think we're just comparing to, let's say, a Macy, for example. If you ever used a Macy or Google Cloud DLP or something like that, that only kind of supports buckets, we're about 1/20th of the cost of running that in a big environment. The last question is, how is the outpost different than an agent? You can't install agents on clouds. An agent typically is, you need to install an agent on each type of data store out there in the market. First off, you can't install an agent on an RDS or any type of hosted database, and that's the vast majority of data stores in the cloud. An outpost is one. It's kind of, you need to think about it as kind of a single location that we install something, and that will essentially connect to hundreds, if not thousands, if not tens of thousands of data stores in a customer environment. You can't use agents in the cloud. It's irrelevant. It doesn't really work for any type of hosted solution. And if I was able to use agents, then think about it. Think about the fact that if you had 1,000 data stores, I needed to install 1,000 agents. Here whether you have 100 or 1,000 or 10,000 data stores, they will install one outpost. And that's kind of the difference between agents and outposts. Cool. Great questions. Thanks for that. On the other side, one second, one more. Is it possible to use a solution for our customers, a license for a consulting organization? Yeah, definitely. We can talk about that further. Feel free to ping us and we'll talk about that as well. Cool. Next topic. On the other side of it, we always kind of talked about discovery, classification, risk, posture, flows. On the other side of it, at Dig, what we built is our data detection and response engine. So when we come into a customer environment, what we built is scenarios of what should never happen with data. No one should copy data outside of your cloud. No one should essentially do a mass download from a data store. No one should take a production database and download that to the local machine, right? Now, why is it so hard to essentially detect? Just by the way, this specific alert today pops up 5 times a day across all of our customer base. And this is one of the most horrible ones, right? Someone is taking a production database and downloading and copying that to their local machine. Why is it so hard to actually detect today? Because the variety of data stores is just too wide. Let's just say that you have 20 different types of data stores, which is a typical enterprise. That means that you need to essentially support, that you need to threat model and identify, how do I identify this across RDS? So if I have 5 to 10 detections. How do I identify this across DynamoDB? Another 5 to 10 detections. How do I identify this across Redshift? Another 5 to 10 detections. Most organizations today don't have the manpower to identify when something bad happens with the data because you have so many different types of data stores and each one of them is completely different. So what we did at Dig is we built scenarios of what should never happen with data. And we have a data research team, and that's what they do. They identify how do we detect something like this in an environment. And we do this across different types of scenarios. Either it is cross recon events, someone enumerating your buckets or having multiple failed attempts to log into a data store. It could be first move events, someone disabling an active security measure like encryption, making an asset public, IAM escalations. It could be attacks, mass downloads and mass uploads and data alterations in production and exports of sensitive data. And of course, it can be compliance events, data residency breaches, data flowing from PCI to non-PCI or from US to Europe. And when we detect something like this that happens in the customer's environment, we're able to not only detect this, but we also bring the entire context to it. Let's just take the example of the bank, data being copied outside to a foreign account. We're able to tell you what kind of asset it was, what cloud it was in, what kind of data was there, who was the actor that did it, the type of account, and the severity. And we're also able to give you all the context to investigate. How did they do it? They did this through the CLI. It can be an API, it can be SDK, it can be through the console. What was the IP that they did it from? The framework, the MITRE ATT&CK framework that was violated. And of course, we're able to investigate anything bad that might happen. So what were the actions that made us trigger? How did they do it? Here we're able to see that we detected this because of a specific action that was done. It can be a single action, it could be multiple actions, it can be an aggregation over time, it can be a sliding window. And not only that, we even give you the raw events that made us trigger about the specific alert itself, and we're able to investigate this further. Lastly, kind of the onboarding piece of it. This is the entire onboarding process. You put the account ID, you give it a name, you choose where our outpost will essentially live in the customer's environment. If it's already installed, we'll tell you, hey, we've already seen it. We already see that you have an outpost. So let's just put the account ID. It's at 12 digits, right? And we're basically done. We give it the name, test account. We choose if it's staging or test and click enable, and basically we're done. Dick will auto install in the environment, and that's basically it. Same goes for Azure, same goes for GCP. It's the same around process. Lastly, reporting. Let's talk about that. Reporting is very important for a lot of organizations. A lot of organizations want to see and visualize to their management what is all the progress that they've been doing in the environment itself. So not only we're able to see all the environments here, we're able to see what is the status, what kind of inventory do we have. We call this a data risk assessment. What's the inventory of data? What kind of information we found? Geographic distributions of sensitive data. What kind of how many assets have sensitive information? What kind of assets do we have? What kind of risks do we have across the environment as well? Which types of risks? And of course, any type of an alerts that essentially was brought up in the environment itself. How many open alerts do we have? How many closed alerts do we have? How are the alerts over time? Which assets have a lot of alerts and which actors are causing a lot of alerts? So we're able to identify this automatically, and this is something that you can show to your management or to your boards on a regular basis. So I'll stop here again. Any questions so far about data detection response and kind of alerting, and of course, all of this can be fed into your SIM, SOAR, Slack, email, whatever system you use today to manage risks and alerts, anything like that. We've been doing really well on questions, so I'm counting on you. Ten more seconds for questions. Oh, there we go. Is there a list of different compliances supported? Today we support HIPAA, PCI, ISO, GDPR, NIST. I think we have a couple of others. We're now building a compliance view of the data. So like we have a risk view here that is more from the security standpoint. We're also building a compliance view on the other side of it. Each security risk is also mapped out to specific compliance standards, but we're building a specific compliance view on the other side of it. So great question, and it's coming soon. What reporting and visualization features do you offer? So I think we visualize where you have your data. How is that data flowing inside the organization? We showed you that reporting capability, but anything is exportable. So anything that you want, you can export to a CSV file. You can slice and dice the information. You can create custom risks. You're able to get our executive reporting, but everything is exportable here in the product. So you don't need to, if you want to put this in a BI system or create your own reports, very easy to do. Any other questions? Or topics that I didn't cover that you would love me to cover? Happy to do it. We have a couple minutes left. Okay. So this has been great. Great questions. 13 questions is a very good number. Also a lucky number. happy to answer any questions, and of course, reach out to our wonderful partner at Onnivation. They can always connect us, and we'll have a longer discussion. The India market is very important to us. We've seen great traction in it already, and we'd love to partner. I think that we can help a lot of organizations not only kind of visualize their data risk and be data compliant and handle this kind of big privacy loom that is now coming on over us, but also help you build better controls over your data in the public cloud, which is probably the biggest risk that you have in the clouds today. So I'm happy to answer any other question as well. And thank you so much for joining. Onnivation team, do you want to wrap up before we kind of finish off? This was great.
Yeah, I mean, this was really great, Dan. And good questions. You were right. Maybe we can wait for a couple of more minutes if anybody has any more questions, and then, yeah, we can wrap it up. But folks, whoever is online, thank you so much. You've been asking great questions, trust me. Right. Dan, thank you for the session.
Of course. Happy to.
As we say, right, one of our best cybersecurity partners from Israel. We made it. Guys, please feel free to put your questions. Okay, guys. So we are hoping that this was all clear, and we also hope that this was a meaningful session for you all. Thank you, Dan. This was really great. And to all attendees, thank you for joining and being with us. Thank you once again. I think we have a question. Okay, no, that's Chaitanya.
Thank you so much. I appreciate it.
Hope you enjoyed the session. Thank you, guys. Thanks, Dan. Have a good evening to everyone. Bye.
Bye-bye.